P. Akla from Computer Science Engineering in Specialization of AI and ML. Today's my topic is signed operand multiplication. First, what is signed operand multiplication? Signed operand multiplication is a fundamental operation in computer arithmetic that involves multiplying numbers that can be positive or negative. Then next, introduction to the signed operand multiplication. A signed operand multiplication involves multiplying number that can be either positive or negative. It is crucial in computer arithmetic as it determines how values are presented and calculated. Understanding signed multiplication is essential for programming and algorithm design. Then next, basics of a signed operand multiplication. A signed operand multiplication is a crucial aspect of computer science and has applications across various fields. First one, representing signs. Computer systems use different methods like 2's complement to represent positive or negative numbers. The next second one, multiplication rules. The signs of the operands determines the sign of the product following basic algebraic rules. Then third one, binary representation. A binary representation is used to represent numbers in computer arithmetic, make it essential for multiplication. Then next, representing the positive and negative operands. Understanding the representation of the positive and negative numbers is essential for understanding how signed operand multiplication works. Positive numbers and the negative numbers. First one, positive numbers are represented using their standard binary form. Then negative numbers. Negative numbers are often represented using techniques like 2's complement, which allows for efficient arithmetic operations. Then multiplication algorithm for signed operand. The multiplication algorithm for signed operand to build upon the back multiplication process, incorporating sign handling. First step, it involves in the 3 steps. First step, ignore the signs of the operand and perform standard binary multiplication. Second one, determine the sign of the operand based on the signs of the operands. Then the third step, if the both operands have the same sign, the product positive or the negative numbers. Then this is the example signed operand multiplication. 2 plus is equals to check the set of the number. Then next, representing number representation. A signed number are typically represented using methods such as 2's complement or signed magnitude. A 2's complement is the most common used method in computer systems. It allows subtraction and multiplication. Then here it is the example plus 13, 0, minus 46 are represented as follow. Sign and magnitude. Here plus 3, sign is 0 and magnitude is 000 110. Then 0, a sign is 0 and magnitude is 000 and 000. Next, minus 46 is 010 and 111 Then next, multiplication of signed numbers. The process of signed multiplication can be visualized as a series of addition and shifting operations. Each bit of multiplier is checked to determine if a corresponding shift and operation is needed. The final result combines these partial products, taking into accounts of sign of the operand. Here a 2's complement multiplication. Here x 5 and x minus 7 is equals to minus 13. Then 0 1 0 1 is the binary number for 5. Then 0 0 0 1, it is a binary number for 7. Then multiplying it, we can get the minus 5 minus 35. Then next, positive and negative multiplication. When two positive numbers are multiplied, the result is positive. When the positive and the negative numbers multiplied, the result is negative. And finally, multiply two negative numbers, else the positive result. Example, addition. Positive plus positive is equals to positive, and negative plus negative is equals to negative. Negative plus positive plus negative are plus positive. Then next, subtraction. Negative minus positive is equals to negative, and negative positive minus negative is equals to positive. Positive minus negative is equals to negative plus positive. Then multiplication. Positive into positive is equals to positive. Negative into negative is equals to positive. Negative minus negative into positive is equals to negative. Positive into negative is equals to negative. Then for the division, positive plus positive is equals to positive. Negative plus negative is equals to positive. Negative plus positive is equals to negative, and positive plus negative is equals to negative. Then next, algorithm for signed multiplication. The standard algorithm for the signed multiplication is similar to that of unsigned multiplication. It involves multiplying each bit of the multiplier by the multiplicand and shifting the result accordingly. The algorithm must also track the signs of the operand to determine the final sign of the product. Then next, using the standard formula, here is the example. First one, multiplying the top number by the digit of the ones place in the bottom. 32 into 15 is equals to 160, and put the placeholder 0 in. 32 into 15 is equals to 160 in 0. Multiplying the top number by the digit in the tens place of the bottom. Then next, add to find the product. The final is equals to 480. Then next, examples of the signed multiplication. Considering multiplying 3 1111 in 4 bits 2's complement, and 4 0100 in 4 bit 2's complement. The algorithm generates partial products based on the bits of 4, ultimately yielding 12 1100 in 4 bits 2's complement. This is the example illustrate how the process reflects the both magnitude and the sign of the operand. The next, hardware implementation. In signed multiplication, it is implemented in hardware using the dedicated circuit in processor. The hardware takes care of complexity of sign handling, allowing software to focus on higher level operations. Modern CPUs often incorporate parallel processing to increase the speed of multiplication operand. Here the multiplication operand for 3. Here the final revision of our multiplication hardware. Then next, performance consideration. The performance consideration of signed operations can be influenced by the number of bits in the operand. Large bit width multiplications require more processing time and resources. Optimization such as Booth algorithm can help reduce the number of required operations. First one, multiplying operations. Multiplying in B, multiplier in Q has sign of A is equals to Q's sign of XOR B's sign of B. Here A is equals to 0, E is equals to 0. Sequence counter SCEC is equals to number of bits in Q. Then Qn gives to shift right E and QS. Then SC. If the Qn is equals to 1 and A A is equals to A plus B. Next, common applications of the signed multiplication. It is widely used in the digital signal processing, graphics and the scientific computing. It is essential for algorithms that requires price calculations such as those in machine learning models. Understanding signed multiplication is critical for developers working with low-level programming and embedded system. And the applications and use cases of the signed operand multiplication. First one, digital signal processing, audio and video processing, computer graphics, scientific computing, 3D rendering and the image manipulation, mathematical calculations and stimulations. Then finally conclusion and key takeaways. A signed operand multiplication is a fundamental operations in computer arithmetic, critical role in the various fields. First one, understanding the basics and the efficiency optimization. Then the last one, widespread applications. Understanding the representation of the signed numbers and the underlined algorithms is a key. Then second one, efficiency and optimization. Various techniques can be employed to optimize signed operand multiplication. Widespread application. A signed operation multiplication has a wide range of applications in computer and other fields. Then conclusion. Signed operand multiplication is fundamental concept in a computer arithmetic and programming. Mastery of a topic enables better algorithm designs and optimization. It is a continued exploration and the understanding of signed multiplication will enhance proficient in computational tasks. Then thank you. Thanks for giving this opportunity.